In this video, we are going to review the distributive property and how we use it to multiply a monomial times a polynomial. First, let's recall what the distributive property says. If I have a times the sum b plus c, I can do a times b plus a times c. An example problem would look like this. If I have 5 times x plus 6, I can do 5 times x is 5x, and then plus 5 times 6 is 30. So these two things are equivalent expressions. They are equal. Let's work through a couple of examples together. Our first example, we are doing 4 times the trinomial 5x squared plus 3x minus 2. I'm going to show every single step. At some point we're going to get to where we skip one of these steps, but I'm going to show everything for these couple of examples. First, I'm going to do 4 times 5x squared plus 4 times 3x plus 4 times negative 2. Actually doing the multiplication, 4 times 5x squared is 20x squared plus 4 times 3x is 12x. And I'm going to be careful with this last sign. 4 times a negative 2 is negative 8, so I'm going to put minus 8. Now this step here, I will typically do in my head. I don't write this step out normally. I'm going to do it for this video, but as you get good at it, that step doesn't need to be written out. You can do that within your brain. Moving on to example 2. And actually, let me backtrack to example 1. Notice that in parentheses I have a trinomial, and my answer is also a trinomial. Keep in mind I'm not combining these because they are not like terms. The first term has an x squared, second term has just an x, the third term is a constant. So I can't actually add or subtract them. That's how I know I'm done with that problem. Okay, taking a look at example 2. Again, I'm going to show every step here. Negative 3 times 2x squared plus negative 3 times negative 1. I'm going to use parentheses there just to keep it neat. Now negative 3 times 2 is negative 6x squared. Negative 3 times negative 1 is a positive 3. Remember, as you are distributing, you are multiplying. That is a multiplication. That is a multiplication. And again, I am done because there are no like terms to combine. Moving on to example 3. With example 3, I just have that negative out there. Remember, what that really means is I'm distributing a negative 1. That's just going to change all my signs. Again, I'm going to write every step for the sake of the video, but at some point we should get to where we can skip this first step. I'm going to do negative 1 times x cubed plus negative 1 times negative 2x plus negative 1 times 4. Notice what that gives me. This is just negative x cubed. Negative times a negative is positive, so positive 2x. Negative times positive is negative, so negative 4. So when I have a negative outside my parentheses and I am distributing a negative 1, notice it changes my signs. This became negative x cubed. This became plus 2x. This became minus 4. Moving along, we need to recall our properties for when we are multiplying with variables. When you multiply with like bases, you add the exponents. So, for example, if I have a to the x plus a to the y, that's going to give me a to the x plus y. That's our algebra way of writing it. Let me show you what I'm talking about when I say we're multiplying with like bases. The bases here are the a, and they're the same. When that happens, you take your exponents and you add them. Notice your base stays the same. So a very simple example before we move on to more complicated ones. If I have x squared times x cubed, my bases are the same, so it stays in x. 2 plus 3 is 5. We are going to need that for our last few examples. Because notice in this example 4, I don't have a 2 on the outside, I have a 2x. I'm still going to distribute though, because I've got a monomial, one term, with the parentheses, and a trinomial. So I'm going to do 2x times 3x squared. Forgot my x. Plus 2x times 2x plus 2x times negative 5. So 2 times 3 is 6x to the 1 plus 2 is 3. It's tricky. You've got to make sure you're using the right rule there. 2 times 3, those are just constants. I just get to multiply them. X times x squared, I'm multiplying with like bases, so I add my exponents. 2x times 2x. 2 times 2 is 4. X times x is x squared. 1 plus 1 is 2. And then 2 times negative 5 is negative 10. You don't have another base, so just negative 10x. Moving right along to example 5. I am distributing a negative x squared. I'm going to try to skip this middle step here this time. If it confuses you, ask me to work individually with you, but I'm going to try and skip that one. And really, rather than saying skip it, I should say I'm going to do it in my head. All right, so here we go. Negative x squared times 2x. Negative 1 times 2 is negative 2. X squared times x is x cubed. Negative x squared times negative 3. Negative 1 times negative 3 is a plus 3. And then the x squared, there's not anything else there to multiply, so it's just going to stay x squared. And we are quickly going to do example 6. In example 6, we are distributing a nasty looking monomial there, but we're going to take it one thing at a time. In fact, this one I'm going to write out that middle step for. So I'm going to do 3x squared, 3xy squared times 2x squared plus 3xy squared times negative 3xy plus 3xy squared times 4y. Now as I multiply each individual one, notice this is a multiplication problem, this is a multiplication problem, this is a multiplication problem. So I'm going to do 3 times 2 is 6. X times x squared is x cubed. The y squared is the only y there, so it stays y squared. Then 3 times negative 3 is negative 9. X times x is x squared. Y squared times y is y cubed. Our last term, 3 times 4 is 12, so plus 12. The x is the only x. Y squared times y to the 1 is y cubed. And that is our distributive property. You are now going to do a few practice problems in your interactive notebook.